Try to get 4 more out before that solidifies. Since I already turned it down or off, this will be iffy. We have water in the others, so this is going to have to completely cool down, solidify, and then we can put the others in here and heat them from cold, because if you ever get a single drop of water in this lead, it will instantly turn to steam and literally explode. Okay, so back to the last one where I was saying this is just another install to touch on the safety equipment. I am wearing the gloves. That's just to keep the lead off my hands. When I'm smelting or anytime I've got my head over the pot, I do have a respirator on. Standing back here, me being 6'3", I'm way above the pot. Lead fumes are generally heavier. What's not, however, is the other stuff that's in it. Lead that's painted, zinc fumes, your other metal alloys, grease, trash, tar, whatever. That stuff tends to burn off and smoke. But again, that's generally in the smelting process, the fluxing process. So you don't need to have your head over it or be downwind from it. Also, while we're doing it outside, I should be wearing long sleeves. I am wearing eye protection, and a good face mask is generally a good thing. What we're going to say about the reason we ease our spoons and stuff into the pots, into the lid, is because cast iron will get moisture, and even lube from the last flux will soak into the pores, and because it's cold, when you stick it in the pot, that's where all this up here on top is from the last time we stuck a cold spoon in it. It heats instantly and it splatters. I have scars, lots of, from molten lead. Several of them did burn to the bone, because this stuff, when it splatters, it's liquid, it hits, it sticks, it solidifies instantly, yet it's still between 500 and 600 degrees, so it just keeps burning. Another one of those do as I say and not as I do things. When you've done tens of thousands of pounds of this stuff, you want to sand your protective clothing, that's up to you. Newbie beginners, especially, a lot of newbie beginners tend to make a lot of mistakes, especially when it comes to temperature, moisture, that kind of things. They tend to get splattered more than somebody that does it a lot. Just saying. Not calling you idiots, just stating facts. And as you can see, that has now started to solidify. And where we're talking about the zinc, if you notice, let me get the spoon, you can see this sandy kind of look. It looks like sand. A lot of people call it oatmeal. But that, make sure my camera feed is up. If you can tell on this camera with the sunlight, the crystalline structure. Now, lead will do that to an extent at certain temperatures. However, this is generally, that's not a lot of zinc compared to some of the stuff I've had. Some of the stuff that looks like pure cream of wheat, or oatmeal as they say. However, that is a good indicator that you have zinc in your mix. And seeing as how this was some sort of electrical, electrical or transformer type connector, then we can see why it was zinc plated. Used to your old wheel weights, you had zinc plated wheel weights to keep down the corrosion from the lead. Then they started making pure zinc wheel weights, which you have to be really careful about if you're smelting wheel weights. You have to take a pair of nippers, you have to check each and every one. Basically, contaminated lead is not fun to work with, and zinc contaminated lead, because of the hardness factor of it, most people nowadays tend to run aluminum mold blocks. If you're running aluminum mold blocks, and I was guilty of this, I did not know at the time, that was my fault for using a basically unknown sourced lead. Had zinc in it, and when it solidifies, when you cut the sprues, especially on the aluminum ones, I basically busted a set of aluminum mold blocks. Just trying to cut the sprues off because the zinc mixture is so hard. The sprues will not cut properly, especially with the cam type sprue cutters, 6 cavity molds and that sort. Steel molds, not as much of a problem, but some steel molds can still be a problem. I actually had to take my steel molds one day. I thought, well, I'll try running it in steel. It was an older pair I had. I wasn't worried about the sprue plate on it. And to get the mold open, I ended up having to take the blowtorch with a MAP tank on it at 1600 degrees and reheat the entire mold and heat it till the bullet mixture, the lead zinc mixture, melted, and then poured it out. I beat and beat and beat and actually beat a cudgel almost into trying to drive that sprue plate off, and it was not coming. So that's where you have to watch out for your zinc mix. A little bit of zinc, I don't mind. I'm used to working with it. I know how hot to keep my molds. I know when to cut the sprue. The problem is you still have to cut that sprue, which we'll get into those terms for you newbies when we get the pot hooked up and the actual molds out. But it will leave a smear across the top. Then you have to take a blowtorch, brass brush. As I said, we'll get into all that later. Just know that you need to know what your mix is. The wheel weights that I run, I know for certain what they are. I know my tensile strength. I run a 89-2-9 mix. So, there's our first go around on the lead smelting. We'll put another one up when this cools down. Actually, that's cooled down now. But I've already got 74 technically, 74 pounds of lead smelted. So I'm going to basically take a break, then I'll come back to this since it's 60 degrees. Day before yesterday it was 11 degrees. So I will be back in a bit, but as for now, we're going to end it here.